Howdy PreCal, it is Ms. Kosh. We are looking at this is our 1C section. So on graphing, this is the second video that I'm making for you. And I wanted to grab a calculator and I forgot to, so I have the loudest desk drawer in the world. I am going to, hang on. I'm going to show you, this is how, when I start with the calculator, I always have everybody clear things. So we go system, F5 helps us reset, F6 goes over, F1, F1. And that's how I reset the calculator. And so we're looking at this one. They've given us this graph. I feel like I'm missing the instructions. Yeah, I didn't write these notes. Oh, here are all the directions. This is what they're looking for. My bad. Okay, so on this particular problem, we can graph this here on, I mean, it looks like it's graphed for us. I'm going to go ahead and into my calculator, I'm going to come to graph this. I see a negative. Notice there's a difference between a negative and a minus. So if you need a negative, you got to use this button. It will change everything if you do the wrong one. 2 times x raised to the third power plus 5x squared minus 3. So there's my graph. And I can just hit enter and go to graph, and that looks great. Notice on this, I can go G-solve. Let's find the max. Okay, and it's finding, whoever did this, they wrote it nicely, they rounded. And then we can do G-solve and find the minimum. And that's going to give us 0, -3 right there. Okay, that's good. So maximum, do we have an absolute? So notice on this graph, we keep going up to positive infinity. So we do not have an absolute maximum. We have a local, or sometimes I might call it a relative. Local and relative, global and absolute. So it doesn't have a global. It has, you could call it a relative or a local. Those can be used interchangeably. But it doesn't have an absolute, because as soon as you think you've found the highest y value, I'm going to go next and I'm going to get a little bit higher. So absolute, there is none. A local, it happens, the local max happens at 1.67. Oh, comma, what was it, 1.63, I think? We have rounded. A minimum, absolute versus local. So on this one, same idea. It keeps going down forever and ever and ever and ever. So there is no absolute maximum, none. The local, I see we've kind of gone here. We have in this area, that's the smallest point available. So that is a local or a relative minimum. And that is the point 0, -3. Okay, interval notation for domain and range. On this one, you notice this looks cubic to me. So we see we have 1, 2, 3 zeros, and I don't see anything else weird happening. It's passing through nicely. I would imagine this is cubic. I also don't see anything that restricts anything. So the domain is -infinity to positive infinity, and the range is -infinity to positive infinity. Okay, so now where is my graph increasing? Well, so my graph, so right now, I always want my x values to be getting bigger and bigger and bigger. Okay, so as I move my x values in the positive direction, what's happening with y? Well, right here, y is going down, 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 down until it gets to this minimum. And then it's increasing, increasing, increasing until it gets to this maximum. Okay, so it's increasing from 0 to 1.67. And then, but where was it decreasing? It was first decreasing from -infinity. It decreased all the way till it got to this minimum at 0. And then we're going to increase it, or excuse me, so we were decreasing, 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 increasing, 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 decreasing, decreasing to positive infinity. So that was no, it's not 67, this was yes, I'm looking at the wrong thing. I was trying to, don't use y values. Yeah, oh, goodness, okay. And to positive infinity. Okay, the point of inflection. Point of inflection needs calculus. Okay, in order to do this properly, you have to know calculus. We're going to come up with an estimate. So this is the bad math. And sometimes when I write these problems, what I will do is I will label it and give it a letter name. So like I might, if I drew something like this, I would do, and I would say, okay, this is where x equals A, this is where x equals B. Okay, so you've got a max and a min. And then I would say the inflection point is where it changes. Notice right here, I'm concave up like a cup. And over here, I'm concave down like a frown. This, x equals C, is called the inflection point. It's where the graph changes concavity. Okay, so in this particular one, we don't have in PreCal, we don't have a good way to find that value. And I'm going to teach you a wrong way. So you have to get to calculus to learn the actual correct way to find that point. But the wrong way is that it's roughly halfway between this minimum and that maximum. Okay, so what I'm saying here is that that C would be the average of A plus B. So A plus B divided by 2. Let's not say equal. Let's say it's approximately. That's bad math, but for our purposes now we're going to go with it. Okay, so it's, what is that? Menu. If I say, well, I had, okay, 0 plus, I know I don't need to do 1.67 divided by 2. I don't have to type in the 0 right now, but I'm doing it because if that were not a 0, this would be how I would do it. So I'm going to say the point of inflection is when x is approximately 0.835. And go ahead and use this approximately because we used bad math to get there. It's close enough for our purposes, but it's not correct. Okay, so where were we concave up? Well, notice back up here, we were concave up like a cup until we got to that point of inflection, and then we were concave down like a frown on the other side. So concave up from negative infinity to the inflection, oh, I'm sorry, you couldn't see what I was doing, to 0.835. We're concave down like a frown from 0.835 to positive infinity. Okay, what I'm going to try and do if I write your tests and quizzes is I'm going to try and use letters so that we don't have to do bad math to get there. In behavior, what's happening? As x goes to infinity, is my graph going up or down? It's going down. So as x goes to, oh, here's infinity. I always do that one first, but not everybody does. Okay, as x goes to infinity, y goes to negative infinity. Let's just cross that out and put a negative infinity. Okay, and then as x goes to negative infinity, what's my graph doing? It's going to positive infinity. Oh, I crossed out something that I didn't need to cross out. All right, there we go. Okay, so let's see. Do you know what? I think I already did even and odd. I'm pretty sure we already did that. I made a whole video on that. Okay, this is similar. Go back and watch that other video. Let's look at the key characteristics. What type of function? I see this lovely, can you see it through the, it's a line. Okay, so it's linear would be the type of function. Its domain, all linear functions have a domain of negative infinity to positive infinity. This range, it's going to hit all the y values. The only, okay, if it's a linear function that doesn't have a range of all reals would be if I had something like y equals 2. Then my graph would just be this, and its only range would be 2. But that's not really what we're talking about. Odd, even, or neither, well, so in order, it would have to have symmetry over the, I'd have to have folded it this way. Nope, it's not even. I'd have to have whatever happened in quadrant 1 also happens in quadrant 3. And that's not true. So it's not odd, this is neither. In behavior, as x goes to negative infinity, so going this way, y is going up. Y goes to positive infinity. As x goes to positive infinity, y is going down, and so y goes to negative infinity. Relative max or min? None. There's nowhere, it's just this nice little line. If you think you have found the smallest y value, I go next, and I'm going to go a tiny bit smaller than you. Zeros, oh look, here is the 0, that's where it hit the x-axis, and you could tell me x equals 4, I would be okay with that. You could tell me it's the coordinate 4, 0. Increasing, decreasing intervals, this graph is going down, 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 down on its whole domain. So it's decreasing on the interval of negative infinity to positive infinity. Point of inflection, none. Asymptote, none. Okay? Into the trash. Sorry. Okay, what type of function is this? This one, it makes a U shape. It's going down. This is quadratic. The domain of a, that's a C. The domain of a quadratic function is all real. You can take any number and plug it and square it and that kind of stuff. This range, okay, so I see that we've got a y value of 4. Well, and everything else is going to be smaller. So we're going to go from negative infinity to this positive 4. We want to include it, so we're using hard brackets. Odd, even, or neither. Well, is this reflected over the y-axis? No. Now, the parent function is even, but the parent function, the only time the parent function, well, as soon as you shift the parent function left or right, it is no longer even. Okay, so it's neither. The next one, in behavior, as x goes to, I'm going to do negative infinity first. We're going to negative infinity. As x goes to positive infinity, y also goes to negative infinity because it's going down here. Relative max or min, it has a relative max at this vertex, so at negative 3, 2. So be careful how they ask that question. If they say, what is the maximum value? The maximum value is the y value, which would be the y value is equal to 4. If they say, where is the max, you would say, where is the max is based on what its x value is. So it'd be at negative 3. Zeros, oh, I see negative 5 and negative 1. You could say x equals negative 5 or negative 1. Increasing or decreasing? It's increasing or increasing, and then it's decreasing, decreasing. So it's increasing on the interval negative infinity to negative 3. We want to use that x value. And it's decreasing on the interval negative 3 to infinity. Point of inflection. Well, this is concave down like a frown the whole time. It never changes to concave up, so there is none. Asymptotes, none. Okay, next one. What type of function do we have here? Here we have a square root curve. Its domain, it looks like we have an x value of negative 2, and then we're going in the positive direction, so we're including negative 2, and we're going to infinity. Our y values are going down, but our biggest one was 6, so we're going to include 6 and go to infinity. Okay, do I have symmetry over the x, not the x-axis, do I have symmetry over the y-axis? If I had symmetry over the x-axis, it wouldn't be a function. Okay, no. Do I have symmetry? What happens in quadrant 1 also happens in quadrant 3? No, so it's neither. End behavior, as x goes to positive infinity, our y goes to negative infinity. And there's somebody at my door. Just a minute. I'm going to finish this problem. And so that's our end behavior. We started here. Oh, hang on.